1860 incremental memory leak. Yeah, so for this problem, this is a simulation problem. We have to understand the question, otherwise we cannot solve it. So the problem is that we are giving memory 1 and memory 2, representing the available memory in bits. Yeah, if we say something like bits, maybe we are confused. Is that a binary base or something? Yeah, so that is just a number. We can understand it as a number. So this is not a binary base. Otherwise, it's gonna be much more difficult. So we have the memory. So let me draw it. We have memory 1 with 2, memory 2 with 2. So our rule says that we're gonna always choose the maximum memory first. If they are equal, we're gonna always choose memory 1 first. Yeah. So this is according to here. At the I second, for example, at 1 second, yeah, the I base of memory are allocated to the stack with more available memory. So this means if memory 1 has more available memory, we're gonna always choose the more available memory first. If they are equal, we're gonna choose the first memory. Yeah, so in this example, if memory 1 is 2, we're gonna choose memory 1. So 2 minus 1, it is 1. Yeah, so this is the first second. Yeah, now we go to the second. So the memory 2 would minus 2, it becomes 0, and here is still 1. Then we go to the then we go to the third second. Yeah, why we go to the third second, the program crashes? Because we need to have at least 3 memories, but one of them is 0, another is 1. It is not possible. So we just return 3, 1, and 0. Yeah. Now let's do the simulation problem. So we're gonna prepare a t. So that is the time from beginning. It is 1 second. So while I'm gonna use the memory directly. While memory 1 more than or equal to 0 and memory 2 more than or equal to 0, we can do something. Yeah. So we're gonna check which one is bigger according to the problem. So if memory is 1 is bigger than memory 2, so we're gonna execute the memory 1 first. But before executing, we have to check if memory 1 times t more than or equal to 0. Yeah. Otherwise, we cannot minus because the memory cannot be a minus value, cannot be negative. Then the memory 1 should minus t. Else, if it is a negative value, so we're gonna break it. Yeah. And similarly for the else condition. So if memory 2 minus t more than or equal to 0, so memory 2 minus t. Else, if it is not, we're gonna break it. Yeah. While jump out of the if else check, but inside the while loop, we have to update the time. Yeah, because for the next time, t would be equal to 2. Finally, we just needed to return this t, memory 1, and memory 2. Yeah. Let's just do a check for this example. So memory 1, 2 more than or equal to 0. If they are equal, so it means here should memory 1 more than or equal to memory 2, because if they are equal, I'm going to execute this memory 1 first. If it is more than 0, so memory 1 becomes 2 minus 1 becomes 1. And for the second step, I will execute memory 2. So the t becomes 2, and this one memory 2 becomes 0, and t will plus 1. T becomes 3, and now memory 1 still more than or equal to 0, and memory 2 should also more than or equal to 0. Yeah, I'm gonna check if memory 1. So now, if I remember right, memory 1 should be 1. Memory 2 should be 0. Yeah. So we're gonna execute this line. Memory 1 minus 3. It is minus 2. So we're gonna go to the else check. We're gonna break it and return the final result. So it means it should be okay. Now let me run it and submit it to check if it works. As you can see, it works and it's pretty fast. Now let's analyze the time complexity. Because it is a simulation problem, so we have to analyze the memory 1 and memory 2 together. So for this memory 1 and memory 2, it is 2 to the power of 31. It's gonna be a big number, but this time is increased 1 by 1. It means it means n squared should equal to this number. yeah, if you know some formula, mathematics skills about that, because normally 1 plus 2 plus something and plus n, it should be equal to n times n plus 1 and divided by 2 should be equal to our target 2 to the power of 31. Yeah, so the time complexity is the square root of this number. If this number is like 10 to the power of 10, so square root is 10 to the power of 5. So this is why we can pass for Leetcode, because 10 to the power of 5 is not a big number. Yeah, so my calculation is just a roughly calculation for the time complexity. Actually, if this number is n, so the time complexity is the square root of n. Thank you for watching. See you next time.